Welcome to Module 3. So by this time, you would have finished Unit 2, Module 2 assignments. And congratulations for finishing Module 1 and 2. So good going, guys. So we have some more modules, and this will be a really cool thing to do, to learn actually. So basically in this module, we're going to be looking at receiving payments, making payments to customers and employers, offering loans to customers, obtaining loans for major purchases, investing money, budgeting, and all that stuff. See, this is what accountants do and what finance guys also do. So all these financial transactions and accounting transactions are pretty much a commonplace in businesses. Business managers need to understand and apply these transactions. And this module will teach you the fundamental math behind those transactions. And it is good to know these math simply because you never know when you need it. So we'll be calculating loan and mortgage payments. We'll be computing maturity value and other investment related values. Now, these maturity values and investment related values, you'll be spending more time on the finance course, which is Finance 408, which you'll be taking. Now, you also need to know depreciation, which is one of the common things that accountants use. And depreciation, there are many methods. We're going to use 3 different methods here, and we're going to calculate depreciation amounts as well. So let's start now. Mortgages. Mortgages are loans from a bank to buy a home, condo, etc. This is a special term that people use. So basically, these are loans. So let's do an example. Let's take the loan term to be 15 years fixed. The interest rate is 4% annual. Cost of condo is $175,000. What is the monthly payment that you need to make? So the interest rate is 4%, right? And this is annual. So first of all, we can say that R, the interest rate, is going to be 4% annual, which is 0.04, because we're converting that 4% to decimal, which is 0.04 divided by 12. And why are we doing this? The 0.04 divided by 12 tells you that it is the monthly interest rate. 4% is the annual rate, 0.04 is the annual rate, whereas a monthly interest rate is divided by 12. That's why we are dividing this by 12. Now, the loan term is in 15 years fixed. So the term, let's say the term can be as n is equal to, now 15 years. So 15 years times 12, and that will give you the number of months, okay, for the term. So with this, we can pretty much use the monthly payment. The monthly payment formula for that is actually P times R multiplied by 1 plus R whole raised to n. This 1 plus R is raised to the power n divided by 1 plus R whole divided power n, that is 1 plus R raised to the power n minus 1. This is the formula that we need to use. All we need to do is to plug in the numbers. The plugging in the numbers, we have P is equal to this $175,000. So $175,000 So basically now, if we do this, we need to round off all these numbers. So rounding off these numbers, this is what I get. You might get a little different value because depending on how you round off. So what I get is for R, I get 0.0033, and I rounded it off, okay, multiplied by, now for 1 plus R whole power n, 1 plus R whole power n, I get basically 0.00597. Again, it might be, some people will get little different numbers, maybe like for instance 0.06068. So depending on the rounding off, this is what you're going to get, okay, divided by 1 plus r whole power n, which is again, I get 0, which is 1 plus r whole power n, which is going to be, hang on 1 second, okay, I need to do one thing here. I'm going to stop this for a second. Actually, this is not this. This is actually 1 plus r whole power n. I'm getting as 1.8094. And then this 1.8094 minus 1 will be 0.8094. Okay, this is what I get. So 175,000 times 0033 times 1.0894 divided by 0.8094, and that I get a value of 1290.77. Again, depending on how you round up and things like that, this number might be different, this number might be different, and this number might be different for sure. Okay, but putting the right, if you round off the right ways like I did, then you'll get 1290.77. So next thing we want to do is find what is the maturity value. The maturity values are used in bonds, as well as when you're going to buy some promissory notes and things like that. So let's take a promissory note that you are executing, and then you want to find the maturity date on a 60-day promissory note dated July 9th. So you want to find the maturity date. Okay, so the maturity date will be like 2 months. Okay, 2 months after, that is 60 days, 2 months, right? 2 months after July 9th. And that is going to be basically, July has got 31 days. Okay, so the maturity date is actually September 8th. So July 9th, then you have August 9th, 30 days, and then September 8th, 30 days. Okay, so you have 31 days and 30 days, and that comes to September 8th, which is going to be 30 days, because September is 30 days basically. Okay, August is 31 days. So the maturity date is going to be September 8th. So you can calculate the maturity dates based on the number of days basically. Now you got to be a little careful about this, simply because of the dates, how it can change because of the months. Okay, July and August, each one has got 31 days, and so 31 days, and so the last day is, so this also is 31, sorry, 31 days, the last day is September 8th. September 9th becomes the new term. That's the reason I take off 1 day, so that is September 8th. Okay, now let's go and do the next one. So here, the principal is $450,000. Okay, the date of note is August 23, the term is 60 days, and the date of maturity is already given to you. So in this case, you don't need to calculate the date of maturity because it is already given to you. If it is not given, from the term you can calculate the maturity date. That will be 1 day less than the number of days. So the August 23, September 23, October 23 minus 1, that is October 22, like we did before. So October 22 of the same year is your maturity date. So it is 60 days. Interest rate is 12%. Okay, so interest rate is 12%. What is the interest to be paid? So in this case, the maturity value will be, the interest rate will be equal to PRT, and that will be equal to 450,000 times 12 by 100. You know why it is 100? Because of the percentage. Times, it is 60 days to how many days? We need to convert it to years because everything is calculated to year now. So like in some time before we did it with months, but this time it is with year. So if it is for the year, then I would put 360. 360, regardless of whether it is a leap year or not, in business, we will use 360 days. So we're going to use only 360 days. And that will come to about $9,000. So let's go to the next one, which is depreciation. We're going to try three different types of depreciation. The first one is the most commonly used method, which is called a straight line method. The second one is called sum of the year digits method, and the third type is called the double declining balance method. So the straight line method is the one which is commonly used in most of the depreciation. Unless somebody else wants to do the other types, everybody uses the straight line method. So the depreciation using the straight line method is the cost minus the resale value divided by the estimated lifetime. So we need to calculate all the cost, resale value, and estimated lifetime. Using that, we can calculate the depreciation. And let's do some examples. So here, the cost is going to be equal to 15,000. The resale value, the scrap value is going to be $3,000 after 5 years. So the resale value is going to be equal to 3,000. Okay. The depreciation is done for 5 years. So the depreciation amount is going to be equal to what we did before, the cost minus the resale value divided by lifetime, the estimated lifetime. In this case, it is going to be 15,000 minus 3,000, that is 12,000, divided by 5. That is going to be equal to 2,400. 2,400. So Bill can depreciate or deduct $2,400 of his taxes from the lawnmower. So if he buys a lawnmower for $15,000 for each year, he can pretty much deduct $2,400. And this is after the scrap value of 3,000. And let's say if there is no scrap value, then you don't need to worry about this 3,000. That'll be zero. If there is no scrap value, it'll be zero. So it'll be $15,000 divided by 5, which is going to be $3,000 that he can depreciate. But usually, every equipment that we buy will have some scrap value, and you need to determine that scrap value. So let's do the sum of the year digits method. So let's say you paid $28,000 for a van for your consulting business, and you want to keep this van for 5 years. You think the scrap value is 3,000, and then on years, what is the depreciation amount if you want to use the sum of the year digits method? So here we need to do something. We need to go by year, we need to go by the factor, and then we need to go by what is called a book value. Okay, so for the first year, it is going to be 5 by 15 times 28,000. It is going to be actually 25,000. I'll tell you in a minute. And that comes to about 8,333. And then you take the $25,000 minus 8,333. That comes to 16,677. So why are we getting 25,000 here? You would have guessed it, because you have $3,000